Very good morning. We'll continue our discussion on acceptance sampling. Already we have discussed about the various terminologies of acceptance sampling, OC curve, different sampling methods, and different sampling plans. And in today's class, we'll take up some numericals. That means how it is exactly applied through some examples and how the relevant things can be calculated. Okay, we'll just take down one example because yesterday I had taken one example about single sampling plan, and we know how to calculate the probability of acceptance. And at the same time, I had asked you to calculate what is the average total inspection for a particular thing. Okay. It goes like this. Suppose you take down again, if you take up the example, that is n is equal to 50, so n is equal to infinity, n is equal to 15, c is equal to 1. Okay. Now, if the lot size is known, then only we will be able to calculate the average total inspection. So let us take up some other example. Say, I will try to be very brief in the sense n is equal to 10,000. Small n is equal to 100. C is equal to 2. Okay. Only this much is sufficient. You are able to calculate. What are the other things missing? If I ask you to calculate the probability of acceptance, can you calculate it? No, is it not? So what is missing here? The missing part here is what quality level of the product has been offered or produced. That is what is important in this case. Let us assume in that case the average fraction defective is around 5%, or I can say that C prime if it is 0.05. Yes. Now you calculate the probability of acceptance of the lot, and on average how many items or the pieces will be inspected under acceptance rectification plan. If it is not that one, then the things will be very easy. There's no problem at all. Calculation. So if it is under acceptance rectification plan, on an average, how many items will be inspected per lot? Now the lot size is 10,000. Sample size is 100. C is equal to 2 and P prime is equal to 0.05. That means what? A lot of 10,000 items containing 5% defective items has been offered for, and out of this lot, that means the lot which contains totally 10,000 items which 5% defectives, a sample of 100 is taken. If this sample consists not more than 2 defectives, then the lot will be accepted. That means it is a single sampling plan. Otherwise, it is rejected. That means the sample may contain 0, 1, 2 and more than 2. If the sample contains 0 defective or 1 defective or 2 defectives, then the lot will be accepted. Otherwise, it is rejected. If the lot is rejected, then what is to be done? The rejected lot will be subjected for 100% inspection. Try to understand. To reject, already you have inspected n number of sample size of small n items. What this one? So first, what are the things we need to calculate now? We need to find out what is the probability of acceptance and what is the average total inspection is equal to what? Now the first thing is, how do we find out the probability of acceptance? That means we need to think under what circumstances the lot will be accepted. When we take a sample of 100 items, what this one? When the lot will be accepted, when this sample, it contains 0 or 1 or 2 defectives. That means what exactly? If I denote probability that the sample contains 0 defective plus, this is single sampling plan because certain notations I am going to use now. This what it says, probability that it contains 0 defective, or you want me to write here, that means under what circumstances probability of acceptance if I put it, is equal to what? Probability that sample contains, that is sample of 100 contains 0 defective, then it will be accepted. Okay. Next, or when probability that, again I will put it that the sample of 100 items contains exactly 1 defective, exactly 0 defective, or that the sample contains 2 defectives. Is it understood? The moment I say in this case, or means it is always the summation. If I say and, it is a multiplication. Try to understand. When you are going to calculate the probabilities, or always means it is summation. That is what we discussed in the first class itself. That is what. And if we use, it is multiplication. That means if I denote the probability that a sample contains 0 defective is equal to P naught, and this if I denote it by 1, and if I denote it by 2, P naught or P1 or P2, or means it is summation, it should be added. That means if I denote probability of acceptance as PA, that means PA is equal to P naught plus P1 plus P2. This will give us total probability of acceptance. What this one? Now how do we calculate this probability that it contains 0 defective? Okay. Now, if we look at this one, which probability distribution you will use? So try to understand, it is discrete probability distribution. Hence, I can use either hypergeometric distribution or binomial distribution or the Poisson distribution. Which is more accurate? Obviously, the hypergeometric distribution is more accurate. But the problem is, calculation-wise, it is going to take more time. And here you can just think that n is 10,000. It is infinity. Much more than 50. And if you observe P tends to 0. And if you observe the sample size n, it is more than 50. What this one? So since the lot size is large, it can be approximated. Instead of going for hypergeometric distribution, it can be calculated by using binomial distribution or Poisson distribution. Again, if we look at P is tending towards 0 and sample size tending towards infinity, more than 50. So the binomial distribution is approximated by Poisson distribution. So we use Poisson distribution. So always try to think that this is what I told you at the beginning itself. The defective, if the quality of this thing is good, what we are trying to find out is, the finding a defective items is a rare event. Hence, most of the time we'll be using the Poisson distribution. Okay? So, probability of acceptance is to be calculated, or P0 or P1 and P2 are to be calculated by using the Poisson distribution. And if the Poisson distribution is to be used, then what is the equation? That means probability that random variable x will take a particular value x is given by e to the power minus lambda, lambda to the power x divided by factorial x, where lambda is equal to np. Already we know n is how much? 100. Okay. NP in the this one. This is what we are going to get. Here, and if it contains zero defective, we will go on finding out. Instead of this one, we can refer the G shown you in the previous classes. G table, that means it is the summation table. There is no need that I need to calculate, provided that it contains zero defective, and then substitute x equal to 0. Then you substitute for one defective, x equal to 1, for two defectives, 2, and then add up. Instead of doing that one, the G table. So what? I will look at 5. That means NP value is equal to 5 under the column 2. That is what I have. .125 plus P1 plus probability that the lot will be accepted. It says that the lot will be accepted is 0.125. What this one? So that means what? Probability it will be accepted is 0.125. That means, suppose if some 1,000 items are offered like this, why I am considering 1,000? Because I will consider these three digits. Instead of 0.125, if I had stopped at 0.12, let me tell, okay, 0.12, then I will think that Let us assume that 100 lots of 10,000 sizes have been offered for inspection. That is what it means. So, it doesn't make any difference. Okay? You can consider as 100 means it is 0.12 will make it. Otherwise, it becomes difficult. We cannot make it 87.5. No. That is the reason. Here, instead of 87.5, what I am considering will be accepted. How many will be rejected out of 1,000? 875 will be rejected. We need to. This is the meaning of that. Or out of 100 lots, 12 lots will be accepted and 88 lots will be rejected. That is what it means. For rejecting this 88 lots, if it is rejected, okay, for example, if it is rejected, for accepting 12 lots, how many have been taken as the samples? Only 100. What is one? For on an average, for each lot, we have taken, out of those 12, we have taken only per lot, 100 pieces have been inspected. Not all. But remain which have been rejected, that means 88 lots have been rejected. For them, what has happened? 100% inspection has to be carried out. What is one? That means how many lots are rejected? That is what we are going to calculate. PA is 0.125. Probably significant digits or 3 digits. Point that is only 2 significant these things, it will become 0.8. Okay, if you take 100 lots, 12 lots, 88 lots will be rejected. To accept those 12 lots, how many pieces have been taken as the inspection? How many pieces have been inspected? Per lot, 100. So likewise, then we have for them, how many are inspected for each lot? 100. So average total inspection per lot, if I want to calculate, accepted lots, it is n plus. For rejected lot, how many lots will be rejected? Subjected for 100% inspection, it is because initially you have taken to reject them, you have taken n samples, already it is included. So when it is subjected for 100% inspection, that needs to be considered. So this will give you per lot. What is one? Per lot, how many pieces will be taken? Point. Right? This is going to be 8,800. 8,812. Otherwise, on an average, per lot, 8,812 items will be inspected. Not the success here what? If this probability of acceptance, if it goes on increasing, then the inspection cost will be reduced. When that probability of acceptance will go on increasing, if the quality of the product is good. Instead of that 0.05, if it were 0.01, the probability of acceptance, it will go up like that. That is what is going to happen. Is it understood? This will tell us how the average total inspection is to be calculated, how the probability of acceptance will be calculated in case of single sampling plan. But now let us take an example how the probability of acceptance will be calculated in double sampling plan. Okay. Let us take that example. Then it makes the things clearer. You take down this example. So you know how to, in a double sampling plan, lot size is 5,000. Sample size is N1. That is N1 is 100. C1 is 0. N2 is 100. C2 is 1. Okay. And again in the problem itself it is mentioned, use Poisson's table to compute the probability of acceptance of 1% defective lot. That means 1% defective. Okay. This problem, so otherwise it would have become more complicated when if C1 and C2 values were more. So for example, C1 value is 2 and C2 value is 4. Then the number of iterations, whatever the values we are going to calculate, it will be more. Because of the paucity of the time, I am considering this simple example. Okay, but at the same time, it tells us how the probability of acceptance are calculated, ETA and other things. That is all we are interested in fact. Okay, once you understand the basics or the fundamentals, the other things will become much more easier. Okay. So compute the probability of acceptance of 1% defective lot. Part B, he says, assume that a lot rejected by this sampling plan will be 100% inspected. What will be the AOQ if the submitted product is 1% defective? Already it is given 1% defective. Again it is repeated. Considering both the inspection of rejected lots, what will be the average number of articles inspected per lot if the submitted product is 1% defective? So what are the things he has asked now? We need to find things. What is average outgoing quality? What is average total plan? These three need to be found out. Okay? Have you understood? This is what we have analyzed. What are the given things and what is to be found out? What does it mean here? Because at the same time, we will try to again recapitulate what is meant by a double sampling plan. $500,000 items which contains 1% defective items. First, a sample of 100 is taken. If it contains C1, that is 0 defective, then the lot will be accepted, will not go for the second sample at all. Okay? If it contains more than 1 defective, because C2 value is 1, then the lot will be rejected. We need not have to go for the second sample itself. Suppose now the lot contains, first sample I take, it contains 1 defective. What is to be done? If it were less than 1, I would have accepted the lot. If it were more than 1, I would have rejected the lot. But it contains 1 defective, then I have to continue the inspection. That means I have to take second sample. In the second sample, how many pieces will be inspected? Again, we will take the 100 distinct samples, and if it contains, how many it should contain? Already you have found 1 defective in the first sample. It should contain only 0 defective here, because it should not contain more than 1 defective, combined defective. That means already out of samples of 200, it should not contain more than 1 defective. Try to understand. That is what it means. Then it will be accepted, because having found 1 defective here, when I take a second sample of 100, it should contain only 0 defective. If it contains 1 defective, the lot will be rejected. Well, it becomes very simple. That is what I'm telling. Okay? This is what is happening. Okay? Now, we'll calculate what is, how the things will be worked out. Now, number of defective articles are how many? 50. Number of non-defective articles are how many? 4,950. Now, if I want to use Poisson table, then what is going to be the value? NP. NP is equal to how much? If I want to use NP value, that means, understand now, when I take out the first sample, Not going to be again mixed back. Second sample, try to understand. Very important concept. This is why it's more likely that the different from first sample to second sample. It is quite possible, or it might remain same. We don't, it doesn't make much difference at all. Okay? Okay? That is how we'll just see also how to calculate. Since the lot size is more compared to the sample size, okay, fine, it doesn't make any difference. Even for the second sample, we can consider it to be n into p only. Because n is also same here, p is also same, so it is going to be same. So it doesn't make much difference. But nevertheless, we need to understand. Because you may have the doubt, okay, that I will try to clarify. What doubt you will have? Suppose you take a sample of sample. If it contains one defective, what will, if it contains zero defective, accepted, no problem. If it contains two defectives, it will be rejected, lot, no problem. But if it contains one defective, what we will do? This one you will take 100 items. How much? Okay. And it should contain zero defective, it will be accepted. If it contains more than one defective, it will be rejected. Now suppose that it contains one defective, 100 items, I mean 99 are good, one is defective. Then what I have to do? I cannot decide, I have to go for second sample. If I have to take the second sample, what is to be done? This 100 pieces, whatever I have taken, I set it aside, or it should be mixed. Try to think, because if you get yourself involved, absorbed with this particular problem, then you will start thinking like this. So, try to mix it, because ultimately what it is, acceptance rectification plan. I have taken out 100, 99 are good, one is defective. That one is also, after this one, I am going to replace with a good item, that we know. But it will never be 100, will be whatever is there, it will not go, or 99, it will not be put back. No. So now, you try to understand. The earlier there were 5,000, but now when I have taken 100 items, then there are only 4,900. Of 4,900 items, I am going to pick 100 items. Since change. So here you need to understand what is dependent and independent event. It will become a dependent event. If I had mixed it, or if I had replaced it, then no problem. This thing would have remained same. It will be independent event. Next, this one. Is it understood? Okay, that is why I mentioned it. We can leave it, however, now. Now, for the first sample, what is that one? N is 100, P is 0.01. So, what is the probability of acceptance of this one? So, we need to refer the GT. So, the NP dash is equal to 1. I will go and I will see it says that it is 0.368. That means probability of acceptance for the first sample. P provided sample contains zero defective is what? How much? 0.368. You got this one? Okay. And how many these things lots will be resurrected after taking the first sample itself? Any idea how to calculate? It is very simple. What is the probability that it consists of more than one defective? That is as good as finding out that one. It is very simple. More than one defective. What is the probability that it consists of more than one defective? If we look at it under that one, more than one defective, that means 1 minus 0.736. So many will be rejected, that much I can say. But out of so many will be rejected after taking the first sample. But after taking the second sample, how many will be rejected? That is also one more point, is it not? After taking first sample, we know how many will be rejected? 1 minus 0.736. And again, some lots will be rejected after taking the second sample. Likewise, after taking first sample, some lots will be accepted. After taking second sample, some lots will be accepted. So after taking first sample, we know that how many lots will be accepted? 0.368. In the general, if you want me to write, what I will write? Probability of acceptance. Total probability of acceptance. Probability that okay. Next one, what I have to write? Probability that the first sample contains one defective. What is one? Probability that the first sample contains one defective, followed by and this is what is to be realized. This is what is to be understood. In fact, so I am using these notations. Probability that the first sample contains one defective. Probability that second sample contains zero defective. Is it understood? These are the various circumstances under which the lot will be accepted. Just now, first sample, what is the probability that it contains exactly one defective? Try to understand. This is 1 means not less than or equal to exactly 1. So again, I will refer the table, or you can use the equation. Okay, that Poisson's equation. It is left to you. But if you want to find out this one, probability of Poisson table, then when NP is equal to 1, under that one, you want to find out exactly one defective, but the G table, it gives the summation under 1. Okay. This probability that the first exact defect, again it works out to be 0.368. So not is to be probability that the second sample contains zero defective. Again, for second sample, I need to find out the NP value. Okay, that percentage defective, whether it has changed or what. Because when I have collected 100 out of 5,000, how many are remaining now? 900 are remaining. How many? Okay. Now, out of that one, we have taken 100 to 4,900 are there. So now one defective I have found out. So how many defectives will be there totally? 49. That means what is the fraction defective? 49 divided by 4,900. Then again it is going to become 0.01. What this one does not change. Maybe peculiar nature of the problem. Otherwise it should be exactly calculated like this. Otherwise also you can ignore this one because the lot size is large. So there is no point, there is no problem. If the lot size were less, then we would have, the accuracy would have been lost. So again the NP value it also to be 1 only. So again if I calculate, what is the probability that the second sample contains zero defect? .368 plus 0.368. So this is going to be 0.1354. So the total probability of acceptance, it works out to be 0.5034. Okay, 0.5034. So that means almost 50% of the lots will be accepted and 50% of the lots will be rejected. Now you try to understand. Add to it. So this is how we can play with it. What this one? Totally how the probability of acceptance, what does it mean? Probability of acceptance is 0.5034. That means like suppose I'll limit myself to significant digits. That means like this 100 lots have been got the inspection or acceptance. Out of 100, 0.50. That means 50 lots will be accepted and 50 lots will be rejected. Out of 50 rejected lots, how many were rejected after taking first sample and how many were rejected after taking second sample? How do you find out? This is very easy way to find out. Because when you take the first sample, how many lots will be rejected? That means I need to find out that probability that it contains more than one defective or these things I need to find out. What this one? Is it understood? That is how it should be calculated. Okay. So now coming back to the problem, totally probability of acceptance is 0.5034. Okay. Now we know the simple thing. What we need to calculate? PA we have calculated. This is equal to AOQ EOQ, I told you, okay? Or if this is small, if you ignore, then it will become 3 into PE. So now, divide, is it understood? So approximately, it is going to work out to be 5.5034 only. Approximately, it is not, not, okay. At the most, it is going to have so much percentage. This is percentage. Earlier it was 1% defective. Now it is 0.5% defective. Try to understand. So the quality is improved or reduced. What has happened? It has improved. It was containing 1% defective, but after acceptance rectification outgoing, it is containing less than that because this is also fraction, P prime, and this is also fraction. If 100% inspection, 100% acceptance, that means 1 means at the most it will consist of P prime only. Try to understand. Okay? So earlier it was 1%, but now it will become 0.5%. This is what is EOQ. Average total inspection. Okay? I think the time is up. Okay? I will just try to calculate this one. Okay? Now, some more time is there. So, the third this thing I am going to. Okay. Now, the probability of acceptance is 0.5034. Calculating this one, you try to think. Why I am calculating this one? Because I am interested in finding out on an average how many pieces will be rejected per lot. For rejected, this one is 1 minus 0.5034. For this one, rejected lot, what is to be done? The 100% in a carried out. That means 5,000. All the entire inspection, the total inspection has to be done. That means 1 minus 0.534, 0.49 0.66. So, 5,000 multiple 1. Per lot, 2,483 will be inspected. Okay, that means rejected lot. But again, to accept now, what I have to do is article accepted after taking the first sample. That means after taking the first sample, how many articles were inspected? What? How many samples were taken? What is one? 100 samples were taken. So that is 0.368 into 100. Okay. How many these things in the first and second sample together? How many? What probability of acceptance was there? That is 368. Items were inspected and plus this one. The 2547. Average 2,547 be inspected per lot, not 5,000, almost 50% of that. That itself works out roughly 50% of this one means that is what we can consider roughly. But this will give us some exact value. Otherwise, approximately we will know. This is what it works out to be. Okay? So I think I'll conclude the session on this one, and you take some of the things as the homework. Okay? That is how to, for example, I'll try to give you the questions. Explain the step-by-step procedure for constructing the OC curve for a single sampling plan. Okay? And draft the OC curve of the single sampling plan when n is equal to, sample size is 300 and C is equal to 5. Let me see how you will work out for this. Okay, bye.